morning and welcome viewers. I am Mr. Anil Kumar Yadav, Assistant Professor at Kashi Institute of Technology. Today we will learn about PDE, Partial Differential Equation, which is topic of second year BTech, second year CS and non-CS. Firstly, we see that here dependent variable and independent variable because we have its need in that topic. So my dear student, now we see that we write linear equation ax plus by plus c at z equal to, and again we write z equal to that one and this one. We have here x and y, two variable, but its value are not depend on anything. Means either at the place of x and y we put any number from real number. At the place of x, y we put any number from real number, and AB is arbitrary constant, as all of you know. ABC is constant, so it will also selected from real number, right? So here x and y is independent variable. Shortly we say this is IV, okay? And z is known as what? Dependent variable, because its value depend on x and y. In same way in second one, in third one, okay? So why we have its need? Because our differentiation going in terms of independent variable with respect to independent variable. So now again we discuss about what type of equation is known as partial differential equation, because earlier you know DE, differential equation. So first very important, very need to contrast between PDE and DE, means partial differential equation and differential equation. Need to must know difference between both. So my dear student, now we come for example of PDE. Here, if any function contain x as independent variable, y as a independent variable, z as a dependent variable, and p first order partial differential equation with respect to x and q. It is also first order differential equation with respect to x and r is a differential equation with respect to x and y, and pq r s, that is s, and after that you have t. Such equation if you have in which x, y, z, p, q, r, s, t, that equation is called PDE, partial differential equation. That equation is called PDE, partial differential equation, and it has two types. First and second. First is linear partial differential equation. And second one is non-linear partial differential equation. Second one is non-linear and first is linear. So how we develop contrast between both? So first of all we need to know what means of linear and what means of non-linear. Suppose you have any equation, independent variable z into terms of independent variable x and y. So that z differentiation with respect to x, that is we say P, means differentiation of dependent variable z with respect to x, that is we say P, and treating as y, means other one, as a constant. Okay, other one left than y means left than x is constant, Now again we have Q, the dependent variable z, again differentiating with respect to y, treating as x as constant. It's very neat, it is very needful, so we writing here x is a constant if your operation going in x. Now again you have r, that is again differentiation of z with respect to x and y both. R is differentiation of dependent variable z with respect to x and y in both terms. And after that you have s, that is differentiation of z with respect to x in order to, and lastly you have P, that is differentiation of z with respect to order y2. Okay, we have here clear vision of P, Q, R, S and T. P is that one, dz upon dx, Q is dz upon dy, and R is dz upon dx and dy. Means your operation firstly going in with respect to x, and after that you again continue with respect to y. So that is dz upon dy, and that is d2z upon dx2 and d2z upon dy2. So on the behalf of this, we create difference between linear PDE and non-linear PDE. So I think if all of you in class 11, 12, at that time all of you aware about order and degree. So if we discuss about this equation order and degree, we say its order is, this equation is P as order is 1 and degree is 1. Its order and degree is 1, and same as Q is also with the order and degree 1. But this one we have its order is 2, means R has order is 2. Okay, but degree is 1. R has order is 2 and degree is 1, same as S has also order is 2 and degree is 1, same as T is also. In PDE, in partial differential equation, if order and degree you have, on the behalf of that you create difference between linear PDE and non-linear PDE. Here linear PDE is what? If that PDE means its first type, if that PDE which have x, y as an independent variable and z as a dependent variable, and p and q, only these alphabets x and y and z, p, q. Okay, so such PDE is called linear partial differential equation. And another one means in linear partial differential equation, all of you exclude RST, and in non-linear PD differential equation, all of you include what? X, that whole variables x, y, z, p, q, r, s, t. If all the variables are present, all or anyone in RST, among three, anyone, at least anyone present, we say that is non-linear PDE, partial differential equation, non-linear partial differential equation, that is non-linear PDE, non-linear partial differential equation. Okay, my dear student. So after that, now we going to create differential equation in general form, or eliminating the parameters constant. So 2 points more, how we make its differential equation means, if we write this one in differentiation terms, dz upon dx, dz upon dy, how we write? Let's see. Now we can erase this, because I hope all of you understand well. Now my dear student, here now we making its partial differential equation. How? You have here f, x, x, 1, z, p, and q to 0. So suppose that our operation going with respect to x. So what? Firstly we did here df upon dx, operation going in with respect to x. Secondly, why? Because our differentiation going in with respect to independent variable, while your operation going with respect to x as a variable, you treating as a y as a constant. I'm just say before. So this is what? This is 0, and this is, now here see, this is dependent variable. So its differentiation with respect to x can possible, and how? Treating as a, that is a function of x. So how? df upon dz. You let that is a function of x, so df upon dz. But you let this via chain rule, you let this z is a function of x, so again we going dz upon dx. That's why happen, because x is z is not x, so we let that is function of x, so its differentiation going in that way. So we let it, again we differentiate with respect to x. Now after that you have p, same as you have did here for p and for q also. Now df dp upon df upon dp into dp upon dx. Now see that which concept you follow, that step, same step all of you follow for this one, right? Now again we have differentiation of dq, and again our operation going with respect to x for q also. Now we have, this is our partial differential equation of linear type, that is linear partial differential equation, because in that you have only p and q, and you can reduce it. How? Because just before I am saying about this, that is dz upon dx, and that is we say p. Okay, so this is what df upon dx, and that is p. Okay, and this is df upon dz. Okay, and this is df upon dp into dp upon dx and df upon dq and dq upon dx. I hope all of you, my dear student, understand how to we generate any PDE, partial differential equation. Very thankful. I'm thank you for watching this video. I hope you will today understand that topic in well manner, and if you like, please subscribe me, and I am continue producing some more videos in same way. Thank you to all. Thanks, my dear student.